So this will be today's agenda. I will kick off with a problem statement I found during research, and then I'm going to talk about the background, objectives, methodology for both physical and digital twin, and also the key findings and the challenges I faced throughout the process of development. I'll also demonstrate in real time how to uh, play with the digital twin later on. So, a basic introduction. Well, this project uses NVIDIA Omniverse to create a desalination plant simulation, improving STEAM education in Hong Kong by addressing theoretical teaching, limited sustainability engagement, and skill gaps. It offers hands-on learning with real-time data, fostering critical thinking and environmental awareness. The initiative supports Hong Kong's water management and educational goals, preparing students for STEAM careers. For the problem statement, there are four major problems I've discovered. The first one would be the over-reliance on theoretical teaching methods. Well, STEAM education in Hong Kong uses mostly textbook methods or even PowerPoints. And it limits students' ability to apply knowledge to real-world issues like water management. It reduces interest in environmental challenges for the students. The second one would be limited practical engagement with local sustainability. Students don't connect with local issues. For example, Hong Kong 70% freshwater reliance on Dongjiang River. They might know that this is a fact, but they didn't know that what could happen if they stopped supplying us with east water. The second would be the unaware of desalination's role. For example, the new recently built Zhengguan O plant, desalination plant in Hong Kong. And then it would be the lack of environmental concern leads to overlooking STEAM's community impact. The third one would be the insufficient in interdisciplinary STEAM skills. While the current STEAM framework doesn't integrate science, tech, and engineering very well, and students are unprepared for challenges like climate change. Lack of interest in environmental issues hinders critical thinking and problem solving. The last one would be inadequate understanding of dynamic technologies. Most STEAM education uses non-interactive resources, for example, like simple PowerPoint demonstration or even in textbook style. Students see environmental issues as distant or irrelevant to their daily lives. And there are limited engagement with sustainable practices like water management. Let's identify the significance of this project. This project tackles water scarcity in Hong Kong. It improves STEAM education by integrating the latest technology using NVIDIA Omniverse. It raises environmental awareness among students in Hong Kong. And it also supports Hong Kong's ESG policy. The key objective for this project is to develop an interactive STEAM learning environment. It should implement data visualization for sustainability and also design STEAM educational activity. Prepare evaluation method for tech understanding to make sure that the students really understand what is happening throughout the simulation. And document guidelines for STEAM integration for future extensions or modifications. For the background and related work, well, there are existing work in STEAM and sustainability. The Hong Kong prioritizes STEAM education with new policies like science subject in primary schools and IT innovation labs. Sustainability education globally focuses on environmental awareness, but integration into curricula is weak. Digital tools like interactive kits are presented to improve understanding of green tech. Well, the knowledge gaps and limitation in imperial work would be the second background issue. Well, STEAM education in Hong Kong lacks practical interdisciplinary learning due to exam-focused culture and limited teacher training. Sustainability education often fragment, not engaging students with real-world issues like water management. Traditional methods, for example, like PowerPoints and textbooks, fail to teach dynamic tech like desalination, reducing students' interest in environmental solutions. And this is a quick glimpse of the physical model and the digital model that I've created. And you can see it in front. Yes, sadly, I cannot turn on the physical model right now because of the steam.
The steam will trigger the water pipe.
Yeah,
We
it
cannot
might
do it
trigger
here.
the water pipe.
Yeah.
So I have used the Arduino and connected into 2 water cups to present the desalinated and yet to be desalinated water. So I believe this project could improve the current STEAM education as it combines STEAM and sustainability using NVIDIA Omniverse for digital desalination simulation. It provides hands-on learning with real-time pH and TDS data. Unlike static resources, it focuses on local context to make learning relevant. So this would be the methodology of the physical model, how it is developed. Well, for the physical model, it first starts with a design sketch. I drew it myself from boiling to condensation and to collection. And then these components are all gathered from Taobao. So basically, a sensors, a Arduino board, and also the electric kettle. And also, I use Arduino Uno and sensors to connect between the sensors and the device as my computer to retrieve data from the sensors. So to design the digital model, well, I didn't start off with NVIDIA Omniverse. I first started off in Blender since NVIDIA Omniverse might not be too user-friendly to design from scratch. So I designed the digital model, mostly digital model in Blender to make sure that it's matching the physical model. And then I imported the USD file to NVIDIA Omniverse and proceed with the physics and particles development. Well, these development are all based on Python codes since the user interface is not very friendly for NVIDIA Omniverse. Yeah, and it includes simulates physics and particle behavior for water droplets and even salt separation. Well, the connected sensors with Python, it retrieves data from the sensors, and we can show an interaction in between the digital twin and the sensors later on during the simulation. Okay, for the delivery of this project, especially for STEAM delivery, well, I developed a guided activity for students to analyze pH and TDS values and its changes, integrating science, technology, engineering, arts, and mathematics. And this would be a basic framework for the virtual lab, as there are some kind of restrictions using the school's computer due to security issues. I couldn't develop a virtual lab directly, but this would be a basic framework. And I also created documentation, including technical reports and educational guidelines, all reviewed by experts in the industry from the current internship office I'm working in, a colleague of mine, and also a teacher, a STEAM teacher friend of mine that helped review the documentations. Well, for the key findings, I've created a fully functional simulation with real-time data visualization that could show before and after pH value change and also TDS value change. And for the educational impact, the STEAM activity and evaluation method, including quiz and feedback form, validated by peers, enhancing critical thinking. And the delivery and documentation, the virtual STEAM lab framework established, technical reporting guidelines complete, reviewed by experts. Well, throughout this development, there are a few challenges and limitations. So the first one would be sensor instability. Well, I've mentioned the sensors are from Taobao. It's fairly cheap, it's not industry approved, so therefore there is some kind of unstable issues that could occur. So the solution for this is to restart the sensor every 2 seconds, making sure that the first retrieval is succeed and then restart it again.
You use software to trigger the restart?
Yes.
Okay, good.
Code
Okay.
to trigger the restart.
Okay, fine.
And the high boiler temperature, well, the boiler reach 100 Celsius to make sure that it boils, right? But the sensor's limits are 80 Celsius only. Well, this is a problem since, as mentioned, It's not industry approved sensors, therefore it kind of cause some problems. Therefore, I designed a cooling mechanism, including the bowl and also a wooden tube to lower the water temperature before sensor measurement. The third one will be rendering performance. Well, even with our this lab computer, it could cause a little bit of problem during simulation due to the particle interaction in between. Well, there are a lot of particles and it could make the computer a bit laggy. Well, in that case, I have optimized the particle system, reducing the emission rate at 100 particles per second, just to make sure that it doesn't force a restart on the computer. For future work and improvement, well, there are limited sensors currently, as I didn't have enough time to develop any more sensors. Well,
You have a part-time
PH
job, right?
Yeah, only pH and TDS sensors right now. In the future, we can add salinity and turbidity sensors for richer data and make sure that there are more interaction in between the students and the Omniverse model. And also the complex UI and fixed variables. I didn't create a new user interface apart from the Omniverse. Well, I simply just made a few buttons to make it easier for the students to work with. And the fixed variables, that is because, well, most of the elements are coded out, and there are some kind of issue as students might find it fairly difficult to understand how to change variables. So for now, it's fixed. Well, in the future, we could use Omniverse Cloud API to call the simulation to a website with interactive variable fields. Well, the third one will be hardware improvements. Well, currently, I did this entire project in this lab right here, and there are still limitations, maybe a GPU limitation or CPU limitation. Well, according to Omniverse guidelines, the best computer is to have an Intel 60-core 4.5 GHz CPU and 128 RAM DDR5. Well, with this setup, we can host an Omniverse Cloud in that computer with all the labs able to run a collaborative virtual lab. Yeah. So this would be the conclusion. Well, I believe this project is not only it's more than just a project. It's a starting point to improve the Hong Kong's current STEAM education system, empowering these young minds to shape sustainable and technological advances.
It is beyond Hong Kong.
Yeah.
I asked China friends, they don't have this.
Yes. So let me demonstrate a bit. Well, this is exactly connected to this computer just to show that a real-time
First, if you like, you can
interaction
go to take a look.
Yeah, and you can see that this is
If you like.
the digital model. Well, I'm going to show how this
Okay.
works first,
Okay,
and
go,
then
go.
show you the codes.
Yeah, okay.
Well, the first we're gonna do is to retrieve the data from the sensors. As you can see, there are changes from here, and then we are going to start the simulation. For the simulation to start, well, as mentioned, as you can see here, the RAM is almost maxed out in the GPU. Oops, sorry. You can see there are particle interaction. You might not see very clearly here. Let me try and use another. So you can see there are particle interaction in this area to do the boiling animation and also how the particle works with salt dropping to the bottom. And then steam coming out with the water level is lower. I can show it a bit more clear by skipping forward. Okay. So, as you can see here, let me hide this first. As you can see here, the droplets are starting to drop. We have to make sure, this is the worst part actually, I have to animate the entire thing with gravity and physics, and make sure the droplets is within this cone, and it drops to the bowl where it fills some water here, and from the tube it will drop back to the desalination cup. So let's continue the simulation. I'm going to skip a little bit to the point where, see, the water level have rise from here, and you can see the water level have lowered from here. And water will start dropping to this cup as desalinated water.
5 minutes left, but you need to be quick so we can have a chance to ask questions, okay? Assuming you yourself 2 minutes.
Yes. So as you can see, this would be the end of the simulation as I fast forwarded. The water would drop into this cup as acting as desalinated water. Well, for the range of the water TDS and pH value, it actually changes the color of the water. But maybe the range is a bit too narrow right now. Therefore, you can see it's using a darker color. So you can see there are salts in this.
Ryan,
area.
30 more seconds so we have time to ask questions.
Okay, no problem. Well, yes, so let's move on to the codes to retrieve the data. Well, I'm showing this last because it gets laggy afterwards. As you can see, every 2 seconds, we will write these data into a JSON file, and through Omniverse, we can retrieve the data from that JSON file. The reason why I can't automate this process is because security issues, again, which restricts me from automating the entire process. Yes, so this would be the end of my presentation.
Yeah.
Thank you
Professor,
very much.
please.
So, okay, and thanks for the very interesting presentation. I think
Oh,
this is
you have the mic?
The mic should be
Do
there.
we need? Okay, here. It will be better. Okay. So I take it out. Okay. Hello. Yes. Thank you.
okay. I think it's very useful for the Hong Kong society. So I have 2 questions. The first is about could you please explain more about how this project will help to address the water problem issues for the Hong Kong?
Well, for this question, thank you for your question. Well, this is more towards an educational area where how we deliver this project to the students. We have to give them a quick intro on what is happening currently in Hong Kong. Why are you drinking fresh water? And then we show this give them a sense of urgency, this might happen in the future. Yeah, and then we can present this model for them this is one of the solutions that we have, and you can extend from the solution, maybe you have better ideas. So it's more lean towards the educational side of the project.
So you mean that this project is for education?
Yes.
Okay. And the second question is about if we want to use these simulation tools, and do we still need this physical device to here run the back end
No, actually. Well, you can run the simulation all by itself, but it will be better with the pH value sensors. Well, the physical model, the most important part would be you can see the Juno sensors and stuff like that, as it interacts with the water levels and water temperature, stuff like that, and convert the data to the Omniverse model. But the Omniverse model itself could work on its own.
So the physical device is only used for the first time to build the model, and then we can reuse this model in the simulation tools
Yes.
for the education.
Yes, and you can see the real-time interaction between the physical and the digital model.
Okay.
Yeah.
Okay. I think it's a very interesting project.
Thank you.
And,
Okay,
no
and
more questions.
thank you, Professor. And since Dr. SCO is there, and I like to give comment instead of question because the whole project idea, well, I need to say that it's from me. And after I learned from many good friends like the Industrial Center from Ryan, and when Professor, you seeing this experiment with a water vaporization devices and digital twin, what I want the growth of this idea would be furthermore. So remember that when we were younger, we take physics class, chemistry class, we were convinced when an experiment conducted A and B together produced carbon dioxide. The teacher says carbon dioxide. Okay, teacher, you say yes. Yes. But if there are opportunities, the student can further experiment physically. I put more A item, more carbon dioxide to be produced. I put more B, nothing changed. Not only that is reflected on the color, but also reflected on a simulation model. So the student will feel I'm in control. So when they feel they are in control, just like we playing video game, our boys and girls spend a lot of time on that because they thought they are in control. So that could be a good opportunity when young people, not only Hong Kong, the whole world, when they doing the physics, chemistry, the STEM experiment in secondary school, when they feel they are in control, they will spend more time. So it's not so I like to keep my opinion whether this need to be maintained. Ideally, it should be maintained because I honestly believe a good STEM education should have more physical items. the digital twin is only a representation of the same thing, so the student can manipulate. Okay, that is the main reason. And I even encourage Ryan or the other future student to grow this idea and promote it to secondary school. Now, secondary school teacher know how to do robot. They don't know how to do digital twin. And with this, I would say, my opinion, the younger generation in Hong Kong or in the rest of the world would be more equipped and competent on learning the STEM. That is the main objective. Whether it is a vaporization or another chemistry, it doesn't matter. That's my opinion. Okay, thank you. That's now we are assuming that it is the official end, and we have an invited guest. So what he say now is unrelated to assessment. You have some comment? Okay, so thank you very much.
Thank you.
唔該晒。咁你直接走啦。So this, I asked my student in China whether they in China have this kind of using digital twin for secondary school education. No. So I asking them to build all this. Yeah. You know when you can feel it, when you are in control, both shifting between a reality model to a virtual model, it's a lot of fun. Okay, that's what I feel. And it's different from ordinary simulation because you have the physical layer. 唔該晒 Dr. SCO， 咁我哋保持聯絡。呢壇嘢仲可以走埋去做我哋個老人 elderly services。OK。冇啊，冇第二個，得呢個嘅啫，係 related to 你嘅，呢個你一定要嚟睇。呢個 boy 幾好啊！阿 Ryan 如果你可以請佢嘅，你可以考慮嘅。不過大班人爭緊。畢業啦。咪咯，呢一科㗎啦。係啊，如果你請佢，你可以揾佢㗎啦。Come on in，OK，set up。你可以 set。呢個又得意㗎，呢個係啊 virtual reality courtroom。變咗如果放翻VA， 你可唔可以你我揾翻你，之後再我再揾你，我哋chatting，OK，做得好啊係。